The shareholders or EADS board actually launched with us on Friday 3 versions. So there we have it. The first airplane, our 350-900, entering service in mid-2013. Then we have the 350-800 coming out in mid-2014, and the 350-1000 in mid-2015. Now, other members of the family, like the freighter and the R version, which you've heard about, will be announced for later dates, but they would obviously be a year or 2 after this point in time. We now have a wider, more comfortable cabin. Yes, it's about 12 inches wider than a 330 or 340. It's 5 inches wider at eye level than a 787, about 3 inches wider at armrest level. We have a lighter, robust, repairable structure, now with over 50% composites, and Tom will take a few minutes to explain what we're actually doing with composites and how it's different from our friends in Seattle. We've increased the cruise speed up to Mach 0.85, and we have the A380 cockpit systems on the airplane. We have new series of engines from Rolls-Royce. It is a new series of engine. It is not the engine on the 787. And it has a common design, common core from the 75K up to the 95,000 pounds. New systems derived from the A380, 10% lower airframe maintenance costs. We have the Airbus fly-by-wire commonality across our entire family.
We've never taken a dogmatic view to the use of materials on the airframe. We've always worked on the basis that we'll find the optimum solution for each part of the airframe with the best material combinations. So you can see here over 52% of the material in composite, and there we're talking primarily about the wing, the fuselage, the belly fairings, horizontal tailplane and vertical tailplane. So what we've tried to do is optimize the material selection for each part of the airplane in terms of cost effectiveness, robustness, and in terms of maintainability. In terms of the fuselage design, we've gone for a shell concept based on 4 sections per fuselage section. That gives us the best way of optimizing the aircraft cross-section, and it also allows us to use the correct material on each shell section to optimize in relation to the loads. And what we're looking to do is to optimize the material mix to achieve that. And of course, to get the better shaping, both in terms of getting additional seat capacity and the optimum aerodynamics, particularly when we talk about in the wing area. So if we make the comparison with the 777, the 787, obviously, as a composite aircraft, comes in about 12% lighter per seat. And what we're aiming to do with the A350 is come in 14% lighter. In terms of the wing, 3 metre larger in terms of wingspan, so we've now got a 64 metre surface area. Much bigger wing, much more optimised wing, and 3 degrees more sweep. And that sweep, of course, was to allow us to go to the 0.85 cruise, the same as we have on the A380. The wing will be in CFRP and will build on the experience that we've had on the A400M program.
And how big is this market? Well, it's worth the wait because the market is pretty big. Actually, 41% of the revenue forecast for all aircraft sold in the next 20 years. They're in the category addressed by the 350-800, 900, and 1000. About 5,700 aircraft worth over 40% of the revenue. Would we like to have it a few years earlier? Yes, of course we'd like to have it a few years earlier, but the airlines I'm talking to right now say it's well worth the wait. Why? Because it's a totally new design. Whenever you come out 5 years after your competitor, you're going to move a generation beyond what your competitor has. You don't come out with a Me Too airplane 5 years later. So we have an airplane that is a completely new design with better levels of efficiency than the 787, a leap beyond what they're offering today. Unrivaled performance, unbeatable economics and fuel burn, as you saw, and we are bringing out a whole new long-range family, the 350-800, the 900, and the 1000, to handle those 5,700 aircraft needed over the next 20 years. That's going to represent 40% of the revenue in the aircraft market.